Sketch rational function. We'll learn the steps which we should incorporate for sketching any rational function. Example is, sketch rational function f of x equals to 3 divided by 2x minus 6 plus 1. Now the characteristics which we are going to look into are vertical asymptotes, behavior near the vertical asymptotes, horizontal asymptotes, and behavior, which is also behavior near the horizontal asymptote, x-intercept, y-intercept, domain range, and increasing decreasing intervals. Now, to find the vertical asymptote, we need to equate denominator to 0. If the denominator is 0, then we'll get something over 0 which is undefined, and that gives rise to vertical asymptote. That point is not in the domain of the function. So, to find vertical asymptotes, what should we do? We'll equate 2x minus 6 equals to 0. So we have 2x minus 6 equals to 0. And from here, we can solve for x. When we take 6 on the other side, it becomes 6. Divided by 2 is 3. So we get x equals to 3, and that is the vertical asymptote. So we get equation for vertical asymptote is x equals to 3. Now let us consider the behavior near a vertical asymptote. That really means is that when we are approaching x equals to 3, then what is happening to the value of the function? So what I will do here is I'll make a small sketch right on the top so that we can refer to that sketch while we are progressing with the solution, right? So what we have got till now is at x equals to 3, we have a vertical asymptote. So let me just draw a line here showing vertical asymptote, and this is at x equals to 3. So I'll write 3 here. So this is at 3. Now, behavior near vertical asymptote is what happens when we try to approach 3 from left side and from the right side. That you can find by placing a value of the function, by placing the value of x as 2.9, close to 3, but on the left side, and then 3.1, greater than 3, right? So we write this as behavior near asymptote is as x approaches 3 from negative side. That means something like f of 2.9 is what? That is what we're trying to say, right? Now, if I have a value which is less than 3 here, then I'll get negative answer, right? Negatively large value plus something. So in that case, we know in this condition, f of x is approaching negative infinity, right? So we can show this like approaching negative infinity in this direction. You see that? So that is what is behavior near the vertical asymptote when we are trying to approach it from the left side. And now let's try to do it, check the behavior when we approach it from the right side. That is when x is approaching 3 but from the right side. It really means that we are checking for a value of the function at more than 3. That means let's say 3.1. What do we get? So you'll find that for a higher value, if we have more than 3, then 2 times more than 3 will be more than 6, resulting into positive part of this fraction, right? And then we'll get positive high number. So we have f of x at this instance approaching positive infinity. So when you approach from positive side, then the function approaches positive infinity. So that is the behavior near the asymptote. Now let's look into horizontal asymptote. Now what is really horizontal asymptote? Horizontal asymptote is we try to check if x approaches a large number, or let's say 1,000, 10,000. In general, we can write infinity. And large number could be both positive or negative. So let's first consider negative infinity. So if it is approaching negative infinity, for example, then what happens to the function? So if we have a very large number here, so 3 over a large number will give us something which is kind of 0, right? So we'll find that it approaches a value 1. Do you see that? But if it is, this large number is negative, then this portion, howsoever small it may be, it will be less than 1, correct? So it approaches f of x approaches 1, but from the negative side, slightly less than 1. So that is kind of critical to understand, okay? But it approaches 1, that is important, right? How about when x approaches large number, which is positive infinity, in this direction, positive infinity. If x is a large number, then this first term will be 0, right? Approaching 0, but positive, right? So positive plus positive 1, they are approaching 1, of course, but from the positive side. So in this case, f of x approaches 1, but it approaches 1 from positive side, right? So this, what I'm discussing now, is actually the end behavior. But what is important here, what you see is that when x is approaching negative infinity or positive infinity, the function approaches 1, and therefore we have a horizontal asymptote, and the horizontal asymptote is y equals to 1, right? Because the function value is 1, right? So what we can do now is we can draw a horizontal asymptote, and let us say this is our horizontal asymptote at 1. An equation for this is y equals to 1. So this point is 1 for us, right? So we got horizontal and vertical asymptote, and we also know the behavior near the asymptotes. The behavior is when it's a negatively large value, then this term is negative, so 1 minus something. It is approaching 1, but from this side. Do you see that? But when we have a large value, let us say 1000 here, this term will be positive. Howsoever small it may be, 1 more than positive means you are kind of here. Do you see that? So that is how it will be approaching. Now let's find x-intercept and y-intercept. Now x-intercept is a point where y value is 0. So you can put y equals to 0 and find x-intercept. So for that, what we will do is, let's solve for x-intercept. That means f of x equals to 0. And the right side is 3. So let's take common denominator of 2x minus 6. What do we get? We get 3 plus 2x minus 6. Now when we say f of x equals to 0, then the numerator should be 0, correct? So that means we get 2x minus or 3 equals to 0, and that gives us the value of x as equals to 3 over 2. So at x equals to 3 over 2, we get x-intercept. That means x equals to 1.5, correct? So 1.5 is kind of middle of 0 and 3. So let's say this is our x-intercept. Now let's find the y-intercept. Y-intercept is when x is equals to 0. Now if x equals to 0, we are trying to find what is the value of the function at 0, right? So if I place 0 in the function, what do I get? I get 3 divided by 2 times 0 minus 6 plus 1. That is 3 divided by minus 6, right? So 3 divided by minus 6 plus 1, that is minus half, right? So it is equals to half. So minus half plus 1 gives us half. So the value of the function is somewhere here, middle of 0 and 1. So that is our y-intercept, right? Now given these points, we can always sketch our function. So let's join them, right? So let's do this and join this. We get our function there, and this is how we'll connect the x and y intercepts and get our function there. So that is how you can draw a rational function, right? You could have taken one more point here, and the good point to take always is f of 4, right? So you can add one more point in your list and find what is f of 4, right? So we'll add it for the time being. So what we'll do is we'll add what is f of 4 for us, just to get a point on this side. So 4 will be, you can find 3 over 2 times 4 is 8 minus 6 plus 1. So that is to give you 3 over 2 plus 1 or 2.5. So this point f of 4 will be 2.5. So we have one more point here to make more accurate graph. Well, that was not necessary, but it could be taken as another point. At times in the question we are required to find a couple of points, maybe 5. Okay, now let's answer the question about domain and range. Now how about domain and range for this function? We know domain is all real numbers, but not including 3, since we have a vertical asymptote at 3. So we can write domain here as x belongs to real numbers, but x is not equal to 3, right? So that is the domain for us. As far as range is concerned, y belongs to real number, but y is not equal to the horizontal asymptote, which is 1. So that gives us domain and range. How about increasing decreasing interval? As you can see, the function really decreases as you move from minus infinity towards positive infinity. In between, there's a break. So we find that the function is decreasing. And decreasing interval is from minus infinity to 3, right? Not including 3, it's not in the domain. And then from 3 to positive infinity. So it is decreasing all throughout. That was expected since the function is really reciprocal part here for the line is with the increasing slope of 2. So if the line is increasing, its reciprocal has to decrease. So that is how we can answer this kind of question and also make accurate sketch for a rational function. So let's have a recap on what we did. Whenever you are given a function, a rational function like this, first thing to look for is the asymptotes, vertical and horizontal. And the best thing is, as soon as you find the asymptotes, place them on the graph paper. Next step is to find behavior near the asymptotes. And then find few critical points. So the critical points which we worked out were x-intercept, y-intercept, and then a value at 4. That results into very accurate graph. Now you can answer the questions like what is a domain, what is a range, and what is increasing decreasing interval. Most of the rational functions which will be like this, I mean reciprocal of a line kind of, you'll find will be either increasing or decreasing depending on the equation of the line itself. If the line is increasing, then the rational function or the reciprocal of that will be decreasing. If the line would have been decreasing, then you'll find function to be increasing, right? I hope that helps you to understand and solve similar problems. Thank you and all the best.